Hello students, a very warm welcome to all of you once again, and today's video is everything is clear in front of you. So, this chapter is second chapter of physics, that is magnetic effects of electric current. Fine. So, now the same procedure I will follow, few questions in a specific category, then few more in some specific category, few more in some other specific category like short answer, very short, multiple choice, or you can say long answer, or you can say hot. Hot means high order thinking skill. So, before the question set is the instructions before that question set is available. So, read the set of instructions only, then proceed. Fine. So, it is question number 1, 2, 3, and here if you just take a look, that is question 1, question 2, question 3 means 1, 2, 3 very short answer type. Just write down 1 or 2 simple words, that is it. So, let us take a look of this question. I have this white and yellow color chalk. Why does the compass needle get deflected when brought near a bar magnet? Answer is due to magnetic field. Simple. Fine. Due to magnetic field of bar magnet. Next question is second question is also very short answer type. Where do the manufacturers use a magnetic strip in the refrigerator? I do not think I should provide the answer of this question. What exactly the answer is? In the door. If you open the refrigerator, you will find a white color plastic lining. This is basically a magnet. So, when you gently push the refrigerator door, it is going to be stuck with that, and then it not allowed the passage of heat from outside or cold from inside. No exchange like that. Fine. So, at the door for closing, that is it. So, this is a beautiful application of magnet. Fine. Then comes question number 3 in the same category. Explain why two magnetic field lines do not intersect each other. Very perfect question, perfect answer. It will start here in class 10th and till class 12th it is same. That is magnetic field lines do not intersect each other because if they intersect, it will show two directions, which is not possible. So, because of this reason, two electric line of forces, two magnetic line of forces never ever intersect each other. Fine. Then students comes question number 4. So, these 3 questions, they were in the category of very short answer. Now, let us see what instruction set is waiting for us for question number 4 onwards. So, this is question number 4 onwards, that is multiple choice, and that too question number 4, 5, 6, 3 questions. Now, one statement, after that 4 options. You have to find out which one is correct. The magnetic field lines intersect at right angles to one another. No, just in previous question what I explained. Intersect at an angle of 45 degree to each other. No. Do not cross one another. Perfect. So, there is no point of reading this instruction. Simply remember, electric field lines, magnetic field lines, both, they never ever intersect each other. Put aside possibility of any angle, never intersect. At any angle, never, never, never. That is it. Fine. So, C is your answer. C. Fine. That is this one. Fine. Then comes question number 5. What is this question number 5? A magnet attracts which material? So, is it possible for the plastic to be attracted by the magnet? The answer is big no. Any metal, now careful, 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 not any metal, copper, gold, silver, aluminum, zinc, magnet will not attract, but aluminum, no, iron and steel. Fine. So, the magnet will, it is not like that it will attract any material, a magnet will attract only iron and steel material. Fine. You can check it yourself, take a small bar magnet, get it issued from your school laboratory or purchase it from nearby stationery shop. Then what you should do? Take some awl pins, fine, paper pins, take some iron nails, take some plastic objects, take some chalks, take some holder, plastic holder, take some cotton cloths, take some copper wire, like that, and then apply yourself. So, this is somehow a question which is based upon experimental aspect. You can perform the experiment. You can have a magnet sticking, no, yes, attracting, this way, not attracting, like that. So, you can classify yourself. Then comes question number 6. Now, in question number 6, it is a soft iron bar is inserted inside a current carrying solenoid. Solenoid is something which, while explaining, I used even a device. Fine. Solenoid, the magnetic field inside the solenoid will decrease, will increase, will 0, will remain same. What will happen? So, first I would like to draw the diagram of the solenoid. Fine. If you are regularly watching our videos, you will say, yes sir, in that particular video you use this a hollow cardboard cylinder, wiring like this. So, now this was the axis of the solenoid. Fine. So, now if I am putting a bar magnet inside, so it will support. So, magnetic field lines inside the solenoid will increase. Earlier it was not like that, but when you place this bar magnet inside the solenoid, it is going to increase. Fine. So, this is the visualization aspect and you can easily find out the answer. Then comes question number 7 to 8. These are high order thinking skill, HOTS. Fine. Now, what is a solenoid? First question. So, solenoid is what? As I told you, it is arrangement of a hollow cylindrical object. On this object, wires are wrapped, fine, and then current is allowed to pass through the coil. So, that is somehow is going to be a solenoid. Draw a sketch to show the magnetic field pattern produced by a current carrying solenoid. Now, try to recall in my video where I explained the solenoid with the help of even that simple circuit. I used even a circuit in that. So, you can say this is the solenoid. So, one pole is going to be act as south as per the direction of the current, one is going to act as north pole. So, you know magnetic field lines starts from north, enters into south. So, accordingly you can show the magnetic field lines. Fine, it is somehow going to be like a bar magnet. Sketch means draw the diagram. Fine, sketch means draw the diagram. Then comes B part. Fine. What is the shape of field lines inside a current carrying solenoid? Straight line. Fine, inside the bar magnet. What does the pattern of field lines inside a current carrying solenoid indicate? So, they indicate what? That field lines start from one pole into another pole. Simple. What type of core should be put inside a current carrying solenoid to make an electromagnetic? Soft magnetic material, because if you try to recall, I devoted 2 lectures on this aspect. One was even associated with electromagnets. So, soft iron material you can put. Fine. So, this is the solution of these questions. Actually, what I did, I tried to accommodate almost all possibilities or questions you can say in this particular question. So, all these concepts are correlated. So, maybe in an exam like they may ask this, like this or this. So, you should have the idea of all these type of issues. Then comes question number 8. Now, this question is up to some extent you can say a visualization aspect. Fine. The figure shows a solenoid the way I was explaining, wound on a core of soft iron. Will the end A be a north pole or south pole when the current flows in the directions shown? Now, the current is going like this, then out, 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 and here it is entering out like this. Now, here visualization is very important this way. So, wire is like this, the current is entering like this. Now, do one thing, move like this. Okay, current is in this direction. Clock face rule, in one of my videos I explained clock face rule, this way north. So, you have to provide the answer of this situation. So, end A will act as south pole, and the rule was this way. Let me remind you. Fine. One possibility is like this and another possibility is like this. I think I should use a different color chalk to show you. Let me allow to redraw it. Face of a circular clock, I have one red color chalk and one white color chalk. Let us say current is flowing like this, and let us say another current red color is flowing like this. I am drawing two diagrams in one you can say diagram. So, now for red, how you can say? Clear? For white, what you will say? You just remember this diagram. Wire is like this, okay? Current is like this. So, I am watching. Which one is? This one is clockwise. So, it is going to be north pole. Fine. And if it is anti-clockwise, then it is going to be south pole. So, visualize in this manner and you will get the answer. Fine. Now, students, in previous chapter previous to this chapter, we studied few formulae. Those were P is equal to Vi, V is equal to IR, P is equal to V square upon R, H is equal to I square RT, those formulae. Now, I will use question 9 to give you a different approach. Actually, this is short answer type, but I want to give you a different approach associated with this topic, that is why I am picking it. An electric oven of 2 kilowatt power rating is operated in a domestic electric circuit, 220 volt, that has a current rating of 5 ampere. Explain the result. Fine. Now, what type of result? Basically, this is associated with resistance mainly. Fine. Now, let us try to visualize this problem. You may ask a question to me, sir, we were discussing magnetic effect of current, then suddenly you started putting these type of questions. Idea is, electromagnetic induction is the mechanism by which you are generating electricity and then you are distributing this electricity. So, electricity you are getting because of this second chapter in first chapter. The current that you used in chapter number 1 is basically you are getting because of the chapter number 2. Fine. So, I thought let us try to use few formulae of chapter number 1 in chapter number 2. So, let us try to understand. Electric oven of 2 kilowatt power. P is equal to 2 kilowatt is equal to, kilo means 1000. Fine. This is going to be 1000. Fine. Then operated in a domestic electric circuit. Fine. So, V is equal to 220 volt, that has a current rating of 5 ampere. Explain the result. Basically, result is associated with the resistance and the amount of current actually flowing. Because you know, if you take, I do not have right now any instrument, but if you take any instrument like mobile charger, like electric iron, like electric fan, anything, and you read it. So, you will find power output this much, voltage operational required this much, current this much, all these things are mentioned. But actually, let us say it is mentioned 220 volt. So, is it like that every time your household is getting 220 volt? Sometimes slightly more, sometimes slightly less. So, rating is different and practically what is happening, that is different. So, first we will try to find out the value of R over here. Fine. So, P is equal to Vi. Now, everything is given over here, but we want to find out R. So, either we can use V is equal to IR, then I can say P is equal to I square R, I can get R, or I can use P is equal to V square upon R. So, both results I am writing. Or fine, get the value of R, and after getting the value of R, when I use this value, fine. So, I will get the value of this you can say resultant current is I is 9 ampere. Actually, this question is slightly twisted in the sense everything is given, but that is on the appliances. 220 volt is operational voltage required, but try to read the instruction manual given with a refrigerator to all of you. Fine, it is a very practical question, this one is. Actually, on the manual of the refrigerator, computer, TV, hot water geyser, anything, it is mentioned operational voltage is 220 volt, this much power, this much resistance, this much current. But then it is also mentioned this refrigerator can operate 180 volt to 230 volt, something like that. It means the range is large, 220 is ideal. So, this question is based upon that type of concept. Fine. Basically, this is something which is mentioned on which? on an electric oven? Simple. Then comes question number 10. A circuit has a fuse of 5 ampere. You know the meaning of this? Fuse wire, I specifically devoted good amount of time to explain. 5 ampere means movement more than 5 ampere current will pass through this fuse wire, the fuse wire will trip down, no current flow. Okay. What is the maximum number of 100 watt 220 volt bulbs that can be safely used in the circuit? Fine. Let X bulbs can be used. This implies that P net is equal to, what is the power of one bulb? 100, total X. So, 100x is the total power required, P net. Then you know P is equal to VI, fine. Now you know this P is what? 100 into X is equal to, what is V? 220 into what is I? 5. Let us try to solve it. 2. So, X is equal to 22 by 2 will give you 11. So, answer is we can use 11 bulbs safely. Fine. So, students, this discussion was associated with 10 questions of your chapter number 2, that was magnetic effect of current. Fine. I hope you will enjoy these discussions. 1 or 2 questions are slightly twisted. So, that will take some amount of efforts from your side. Okay, this is asked, fine, like this. Soon I will come back with some new videos of some questions, of some concepts of next chapters. Till then, take care of yourself. Have a nice time. Thanks a lot.